We've been students now for almost 3 years, so we've had quite a bit of experience with AutoCAD. That's the program that we used, and we've had quite a bit of experience designing, meeting specifications, meeting deadlines, fine-tuning things. So ultimately, that helped us to create what we like to think is a perfect beam.
Our major concern is trying to keep the cost of the beam down. So hitting a target for strength, we knew where we had to be, and then just tried to make the beam as small as possible with as few components as possible.
We went to PSI in Windsor, Ontario. And they gave us a hand setting everything up and helping us with pouring of the concrete, and they supplied all the material for us. The most difficult part of manufacturing the beam was when we went to put the tensioner rebar in, we had a problem with it falling down inside the formwork under our stirrups, and we had a hard time getting that back up on top of the stirrups.
The method of testing is we went to a compression test, and first we tested the cylinders after 1 month, 28-day break, and then we tested those cylinders in compression and also another one in tension. And then later we applied our beam to the main structure for compression, which you will see in the video later. And we test our beam, and it just applies the load down 1 point, and then it spreads into 2, and then that goes into the beam. And then we should see cracks as per the design, which should have been around 89 kilonewton, and we seen our first crack at approximately 95. Concrete is good in compression, and so when we added the steel tension lines into the beam, it gave it kind of an arch, kind of like the back of a tractor trailer. So when you apply the load, it'll flatten out, and then when they apply more load, it'll bend, and then you'll see the cracks forming on a 45, and then eventually, if you designed it correctly and built it correctly, it should break where you planned on it to break, and eventually that's what happened for us. Planned our beam to break at approximately 155 kilonewtons, and we broke at 152, which is exceptionally well.
Well, we noticed a big void on the flange there, just at the bottom of the web, and it was kind of alarming. And then so we had to rip off the excess styrofoam that was still on there. We noticed it was a pretty big sized hole, and we noticed that's exactly where it cracked.
And that's kind of the trade-off of having the I-beam. So we managed to bring the size of it down substantially. Our web was only 100 millimeters wide.
Yep.
But that made it difficult. So we traded excess material for difficulty in consolidating the bottom.
In the construction process, yeah.
So yeah, maybe next time you'd probably turn around and use some SCC concrete.
Yeah, there you go.
It broke on a 40.
Everything gets in there.
It broke on a 45-degree angle though, so I mean that is a perfect shear right there. That's a great break.
That is true. And it broke with a boom, so
That's always good for TV.
The goal of the Big Beam competition is threefold. One, to expose students to concrete industry practitioners and also the concrete industry in general. And secondly, to enable students or to give students an opportunity to learn how to design in real life and also to construct and manage projects. Finally, to enable the concrete industry to market concrete as a sustainable and economic building product. For students, obviously, any opportunity to engage with industry is an invaluable experience, and this competition really helps students who are competing to come directly into contact with engineers and producers of concrete products. They learn the technologies and techniques that are used in industry. Students get exposed to leading edge technology and also materials that are in use out there. Well, this is the 4th year that Fanshawe students have engaged in this competition. In the first 2 years, we came second in Zone 7. Zone 7 being, and remember, this is an international competition, so Zone 7 includes all competitors outside the US. So we're talking about Canada, South American countries, the Caribbeans, and so many other countries. So as I said, the first 2 years we came second. In the 3rd year, which was last year, we came, I believe, 4th and 5th. And this being our 4th year, we are hoping to come first. Well, I think it's an exciting opportunity both for the college and also the students and the faculty who are involved in this competition. I'd like to thank Ms. Amne Kalush for spearheading this year's competition and walking the students through the various stages. I'd like to thank the students, the 2 student groups that participated. And finally, I'd like to thank the college for putting things in place to enable our students to be exposed to this invaluable experience. Thank you.